Hello everyone, now I'd like to continue our session by sharing how to use the digital query name DNS name server. We also explored how to contain the minor system for queries and related configurations. Following that, we will dive into how to distribute denial of service traffic attack parade. And just be quick hands up. I have already updated all query tools we use today, so please hurry to download and access them for your convenience. Let's get started. Additionally, I'd like to introduce a tool called Maltego. First, we need to register an account. Of course, you can simply use the free type to conduct basic queries. I'm already registered. Let's see, I have created this target. Let me open the website to search the godfather of scammer-based Chen Zhi, and let's do it started. Maltego offers a wide variety of plugs or transformers that we can download. Once we set up, we select the name and drop to the blanket. And let's run the inspection. The tool will directly query and visually map out exactly who has been communicating with the addresses. Once we uncover this connection, the possibility of was we can use these to analyze the component data leakage risks. Naturally, this holds immense intelligent value, whether it's investigating criminal activities, internal employee communications, or tracking phone numbers, locating coordinates, airline flights, bank transactions, and even credible currency addresses. It's incredibly valuable. Next, let's use the dig tool on tour. And here we receive a lot of information such like flags, desire, set the client like your computer during the query. One indicates that you wanted the DNS server to perform a recursive query to resolve the domain. 0 indicates an iterative query, and the RA its recursion available indicates whether the server supports recursive queries. Next, we can take a look at the UDP port states is Nmap. We can Nmap -s. You can use this Google IPs. Let's see the feedback accurate, the query back. Another tool we can use the NS lookup.
Let's look up and then we first reset the query tool. Query type equals SOA, then domain swig we meet pieces dot. So we can see queries answer the information, non-authoritative answer, original, and this one. This is limit server. Specifically, the authoritative limit server. This zone is used for the zone findingness, thickness, mail addresses. This is the demonstration and email address. Notice the DNS record. The first dot rips at, so actually the mail assistant at makes host.info. The serial this is record was modified for a second time on January 12, 2026, and the refresh as a refresh and retry. This is however expired, usually like it looks like 10 plus days minimum. This was negative caching time to length. If someone query a LAN extended domain, the DNS server cache the negative response for 10 minutes to save bench. Next, we will set up limit server a fully controllable local label environment to safety conduct DNS resolution and vulnerability testing. Before we started, there are 13 sets of root limit server globally. Although their core management organizations are primarily located in US, Europe, and Japan, thousands of root server minor nodes have been deployed worldwide using the any-cost technology. This means that even if some nodes falls, and other miners can be ensured they normally operate in the global DNS. We will use the BIND9. You can visit the website to generate do not to go the official website, download the individual configuration file, take a look. Usually you install it directly via the systems package manager. We can just directly type the command sudo apt install and BIND9. It will be after system will be automatically generate default this configuration file like lame server lame config, and the file is saved by etc and we can cut Once installed Linux, as default configuration file is installed /etc/bind with the current file name being lame.conf. If you're convenient, I have uploaded the modified configuration file to GitHub for you download and use directly. After modify the configuration file, we use the run sudo system called restart and BIND9. Type your password. BIND9 is not found. Restart. Okay, my BIND servers are been started and running. Additionally, if you prefer not to configure it manually, you can directly download the prepackaged experimental environment ISO image from the Hacking House, the official website that have been already tested in the virtual machine environment beforehand. Everything's running perfectly. You can follow along and try it by yourself. We will continue using the DNS query method. So we will use the dig at 7. This is my local any NASA.government. The server has been private authoritative name server response. We can use SOA authoritative reply, and the NASA servers are responsible for the zone5 and ANS1 and ANS2, and there is also 2 mail server and the any flags and an example for us for any available record and also it with the domain. Let's query A. Allows to query authorized record. And another way to query information specifically to find the result records the zone file information is let's see, yes, use cards and version.bind.txt. Use the query to request the server and try a response. This is my local host loopback array. This means we are querying the DNS server running on the current server because I already started my local BIND9. I deployed my local. Now the cost class is specifically reserved for querying server metadata and management information. And the version band specifies the domain name query with the cost class. This is special built-in visual domain specifically used to store in the version stream of the band software. Text is specific to the query record type and return plain text information. If I return the answer section display and the band server version is the specific version, and it's the same. So the version is here, and the specific version number has been exposed. Now let's look at highly realistic target using the methodology, and we use the domain londonic.com. First, we execute our whois command london.ic.uk, and look in at the output. We don't just see the registration detail. We immediately identify the authority name server, specific as0, as1, and 2, and here we get it. Then armed with this, we escape the public DNS resolve and aim and directly on the source. We run our dig command point at the LAM server. Dig at and but notice the end of the command instead to asking for specific recording like this. So we use the any flag, then we are essentially asking the server, give me everything you have on this domain. The server responds and authorization answer, and there's flags in the query 1 answer, and this query 1 additional 1, and hands over and go to my NIE record. Let's analyze intelligence. We just gathering an a record.com This instantly tells us about their internal IT environment. They are intending Microsoft's infrastructure for the corporate communications. Finally, the text records, we can clearly see the sender policy frame configuration. This tells us exactly which internal servers are authorized to send emails on behalf of the university. For a security professional, Net is crucial for assessing their vulnerability in email proofing and phishing campaigns. We may use the dig and add let's try this calls version bind text. Now let's look at the result of the version bind query against the University of London name server. If you look at it closely and the output, you will see states no error. But more importantly, answer 0 instead of giving a text recorder with a software version. The server simply returned a generic SOA recorded authoritative section. What does this tell us? It tells us their system administrators are doing an excellent job. They have activity and hidden their DNS configuration to hide software version. In cybersecurity, preventing information disclosure is a fundamental defense mechanism. But by making the version, the denial attack the ability to Nmap the server to know vulnerability or specific exploits. This forces any potential attack to work much harder to find entry point. Let's dig by ourselves. If the command is successful, read back the response, the real host names and attacker might be used on that name server to guess your company internet internal framework. For the security case, usually the administration will be changed the band of configuration file. We can use them. We can change it. The file is one we call the name conf. So this one, we need the host name. We need the host name to change the name. We need to take a look at this file, and then usually the configuration files can save it to these options. Let's take a look. Here is a dictionary, this one. We made to add downstairs version line, no need, or version unloading the server or something. Then we can see this system call restart lane. So after we repeated, this band server version will be totally hidden. Now we have the IP address of the targeted DNS server. Now we have the IP address of the target DNS server, 183.63.88.11. The next logic step or reconnaissance is to test the network ports. Specifically, We wanted to see the TCP port 53 is open, which is critical for testing zone transfer vulnerability. Traditionally, many people would use the turn9 command for quick connection test. Let's try that turn9. Paste. As you can see, we get a command not found error. It's a very common sensory modern operating system have been deprecated turn9 because its transmitted data is plain text, making insecure. But as security professionals, we will have alternatives. Instead of turn9, we use the night card. Often referred as the Swiss Army knife for networking or our train Nmap. Let's night card the command mc-bz and paste the IP address and let's go. Forget to put the port. Excellent. As we can see from the netcard output, the connection is success. TCP port 53 is activity nothing. That's why is it a critical finding? Normally, everyday DNS queries operating over a UDP. However, TCP port 53 is optimized for handling large responses. Mostly notable DNS zone transfer technology known as AXFR. Or zone transfer is the mechanism meant for the primary and secondary DNS server to synchronize their databases. However, if the administration misconfigures the server and leaves open to the public, anyone can request a zone transfer. That would be force the server and down entire DNS database, expose every single subdomain. An internal server and piece of infrastructure their own. It is holy grail or reconnaissance. Since the port is open, thus our duty as a security professional test if properly secure. We will attempt a zone transfer right now using following command D and add that's random domain dot uk and xfr. Let's see if the server allows us to download some material file. And there we have it. The output clearly states transfer fault. While we successfully discovered the TCP port 53 was opening nothing, the target service did not hand over the database. Why? Because system administrators have implemented proper access controls. They have configured their service only allow zone transfer specifically on whitelist IP addresses. Their own secondary name server or unauthorized request was completely blocked. This is a textbook example of strong where configuration defines mechanism and reward. Our reconnaissance phase has yet valuable intelligence, but the Chrome database remains secure. That's in the real world to take a query dig as how is the deliver server. We can create this one. And the calls ID dot bind 60. let's look at one final advanced reconnaissance attempt. We're just querying for ID bind. This is technique often used to identify the specific internal node response to us, which is specifically useful when targeting large distributed networks, but looks like response header states refuse. Unlike our previous query where server politely gave us an empty answer, here is activity slamming the door in our face. The IT security team has explicitly configured their access control list to block their types of internal different queries. This is conclude our intelligence gathering phase. We will see how a map of infrastructure, and more importantly, we will see how what definitely enterprise network looks like the real world. Many people might wonder, isn't DNS query traffic use the UDP port 53? And does it make any sense to test the TCP port 53 use Telnet? It makes perfect sense because DNS simulating utilized for port 53 both UDP and TCP 123. And generally, web page domain name resolution by client defaults to UDP port 53 to achieve maximum speed. When DNS response package 2 is too large, exceeds 512 gigabytes, or when zone transfer occurs between DNS server, it automatically switches TCP port 53. Modern domain name system security extensions relies heavily on TCP due to large size packages contain the cryptographic signature. And DNS recon, and we can dash d domain lasa dot government. The common use is the DNS recon to force all traffic to your local DNS server in 23.1. I'm performing the comprehension DNS information gathering security against NASA.gov. DNS recon is highly powerful and advanced DNS reconnaissance script built in Kinetics. It offers more modern and comprehensive functionality than FICE, which you used previously. Automatic DNS reconnaissance tool used the guard DNS record and map out on the network topology and target domain. Specifically, the target domain is -D stands for the domains -N. Specific DNS server used for queries -N stands for limit server. This is force that tool send all requests to your new deployed log bind server rather than using the system's default DNS. Let's echo VPN. Permission didn't. Okay, ready. DNS enum -- discard DNS server and NASA.gov. In the real world, penetration testing and getting only a single subdomain like VPN is far from enough. Kali comes preloaded with professional, massive dictionaries containing thousands of common subdomains. If you want to perform a realistic brute force simulation instead of memory echo in words, you can directly point past Kali building the word list. Return to the next we will dive into the MSF exploit console. We will utilize the Metasploit framework that is highly similar to Recon-ng, and upon loading you will see the same code feature flashing the red zone and the green zone. To view it, all comments in entire MSF console and all output displayed on the terminal screen will be recorded into log file. This is extremely critical for reviewing the penetration process right penetration testing report. The log life in MSF range from 0 to 5. Life 5 is highest debugging model, and which is recorded extremely detail high-level communication data, and model loading process and the error messages is typically used when the troubleshooting the following module development task deploys. Setting session as true. This one's most practical features in the penetration testing. Once you successfully create or share a manipulator session on target machine, all actions you perform within that session will be saved in separate. Even as a session drop unexpectedly, your records are not lost. This one timestamp output true. This prints time for front every line and output in the MSF console combined with the login feature mentioned above. You will extract exactly to minute and second when a specific attack was executed and when the response was triggered. The DB states this is applying the command ensure that every time you launch MSF console, the terminal immediately auto-reports whether the database is connected, saving your hassle of typing manually. Okay, our databases are connected. Then we will reload the console to start it, and you will find the DB states. Let's see, already connect. Let's look at the help documentation first. It's very helpful to also for its usage. Shell-h. And we all penetration attack module exploit. and via jurisdiction module. And shell payloads. Post the post exploitation module. In practice, we will really use the shell and to plan it to fit through thousands of modules. Usually, people to combine it with the search command to precious lookups. For example, since you've been playing with DNS related security testing, if you want to see what modules Metasploit has been attacked in the scanning DNS server, you should enter the SLS modules search DNS. So all DNS will be here, and the module. Well, let's take a look at this module is powerful, and it automatically helps you test in zone transfer, brute force subdomains, and execute various standard record queries, setting target IP point in your locate server, and we can set shell options. Let's take a look. First, we need to set setting domains on the database. We word a weapon dictionary early that we can be loaded directly. Not always find leave empty if you don't edit. So we can say all the word is the password coding, and this is the passive seen by Kelly building goodness in and DNS.txt. Let's run. This can successfully retrieve massive amount in NASA real public DNS record on the internet. This also proves that your previous system DNS modification was a complete success. Your local band server has successfully enabled the forwarding function of the external internet after receiving the request from MSF it went to internet itself heavy from NASA real cards and returned them. The modified force discarding who hosting the domain for large document technique analyzed, and the return results are Recon-ng. This indicates that NASA have outsourced the domain resolution server to Akamai and Akamai. The world's largest city and the security provider leverage it globally distributed network deployment DDoS attacked from hackers. And zone transfer attempts. It's highly aggressive. It extracted the real IPs and Akamai survey just found looks like the IPs and attempt to food and transfer down all requires against each one. This suffix have changed to MIL. This is US military exclusive top-level domain. Here is the general military mail gateway and the CSC.MIL represents the National Cybersecurity Center. It means the email sent by NASA must be go through the cleansing and screen of the military and cybersecurity center. And here, the means is start authority record define the global control center for the zone. This is exposed the real internal DNS master server host name in NASA as pen testing as a host name is often a highly valuable target for directly internal penetration. And also the text record storing the sender policy framework and spoofing by list. It's telling more the mail server worldwide only email sent from and the IPs like 214.2960.2 as well as the Amazon SES mail server and claiming to be NASA government are genuine. Everything else is fake. No return out on internal network environment send the NS parameter to local. We should be set NS. That's the view correct, and the second then download the password and calculating is the user and share DNS num and DNS.txt. Set or list user then that will start to be internal. Ban the server. Also, you can see all our query are back. So next way we can use not just only one Metasploit framework, but also the Nmap scripts. When you use this port scanning variable, we can run Nmap scripts local, perform fingerprint searching and enumeration. We run them directly, and this tool also I already put my GitHubs. You can take it and then hurry. We run the detection directly and list many useful scripts. We can also need to see problem-based asymmetric traffic amplification tools. We can use the DNS brew, and we copy, and here we are ready to change to update the files. Then we will to paste. DNS brew. Paste and script DNS brew and the dash script arguments. DNS root and dot domain equals master.government localhost nmap dash script DNS root script argument. Okay. Let's go. because we edited the script and the dash arguments directly load the default massive dictionary during the pre-scan phase before the actual scan started. Not only did it successfully get the VPN that you planned early, but it also built out all hiding subdomains configured in this log band at once, like WAM 3W and 3W and firewall. It even thought for grabbing the IPv6 addresses. Okay, so we got and let's operate that directly on the real world environment. Let's type there. We got any IP addresses. Take this one. Which is beautiful, execute pieces of information gathering. just too long time, take a long time, and after you may try by yourself. The Nmap accidentally gave it on Japanese, so fully ported his check. The host had the door wide open, exposed many traditional internet servers like FTP, SSH website, and the complete mail sent on the receive system, 10143, and in real penetration testing, these open ports are excellent entry point for subsequent weak possible brute forcing or version vulnerability exploitation. So let's return MSX console, and we can use another tool, use search DNS AMP. This is DNS amplification tool scanner. DNS AMP. We can analyze this auxiliary module. It's not part of the exploit framework, but it's specifically designed to execute specific tasks. Let's use it. Paste. Let's see the domain government. In this testing result proves that your locally deployed DNS server is vulnerable to DNS amplification attacks. What can be hacker achieve by exploiting the vulnerabilities? If DNS server of your very exposing public internet, a hacker could forge or victim or IP addresses, IP spoofing, and send 767 bytes query requires your port 53, and in response, your server will flow in the victim with 487 bytes junk traffic loads. By consuming only 1 GB of their own bandwidth, the hacker could leverage server like your Pro 7.27 gigabytes BPS of traffic onto the victim, thereby launching a massive DDoS distribution denial of service attack. The perfect substance what is discussed earlier regarding why modern DNS server restriction is external any request by default. Without these restrictions, there are easy weapons as traffic amplifiers.